In this video, we are going to talk about trig integral part 1, sine and cosine integrals. Before we start this part, let's review some important trig identities. I here recommend you try to remember all of them, at least be very familiar with them. They're very useful when you try to calculate the trig integrals. Sine and cosine integrals. I will calculate the integral of product of sine x and cosine x with relative power of m and n. There are three conditions. M and n. There's only one odd number. M and n are both odd number. M and n are both even number. Let's see first condition. M and n only have one odd number. In this condition, we will need to add 1, split a factor of, and put with dx. Let's see an example for us to understand. Integral sine 4x cosine 5x dx. First thing is, there's only one odd number, that's 5. So we will split 1 cosine x off the cosine 5x, and we will have cosine 4x times cosine x. Thus, we will have du equal cosine x dx, u equal sine x. Then we substitute sine x with u. We'll get integral u to the 4 times. Then we will have cosine to the 4x. That will be 1 minus sine squared x squared. And here we directly write down 1 minus u squared and squared. Cosine x dx is du. So we last write down du. And then equal integral u to the 4 times 1 minus 2u squared plus u to the 4th du. And then equal integral u to the 8th minus 2u to the 6th plus u to the 4th du. Then we can use integral to calculate. Equal u to the 9th over 9 minus 2 over 7 u to the 7 plus u to the 5 over 5 plus c. Last, please remember to substitute u with sine x at your solution. Equal sine x to the 9th over 9 minus 2 over 7 sine x to the 7 plus sine x to the 5 over 5 plus c. Let's see the second condition, which is both m and n are odd number. In this condition, we will let bigger one be u. For example, integral cosine to the 11x sine to the 5x dx. Here we can see 11 is the bigger number. So we will let u equal the bigger one, cosine x. So du will equal negative sine x dx. So we substitute cosine x with u and substitute sine x dx with du. We'll have integral u to the 11 times. Here we will be very careful that there is a negative for the du. So we'll put another negative in front of the sine x to the 4th. and times negative sin x dx. And we know sin x to the fourth we can write in 1 minus u squared and squared. So we will get integral u to the 11th times negative parenthesis 1 minus u squared parenthesis squared du. And we'll get integral negative u15 plus 2u13 minus u11 du. We calculate the integral, we get negative u to the 16 over 16 plus 2 over 14 u to the 14 minus u to the 12 over 12. Finally, don't forget to put cosine x back, substitute u, and we'll get our answer equal negative cosine x to the 16 over 16 plus 1 over 7 cosine x to the 14 minus cosine x to the 12 over 12. Let's see the third condition, which m and n are both even numbers. In this condition, we will need to reduce the powers of sine and cosine. Recall our trig identities. These two identities are really important for us to apply in this kind of condition. Let's see an example. Integral sine x squared cosine x squared dx. We will see m and n are both two even numbers. So here we need to reduce the powers of both sine and cosine. Here we get integral 2/2 times 1 minus cosine 2x times 1/2 times 1 plus cosine 2x dx. And then we get 1/4 out of the integral, and inside the integral we'll have 1 minus cosine 2x squared dx. We will apply, reduce the power again, and then we will have 1/4 integral 1 minus 1/2 times 1 plus cosine 4x. So here is 4x. It's very important. Don't forget to double. And then we will have 1/4 integral 1 minus 1/2 minus 1/2 cosine 4x dx equal 1/4 integral 1/2 minus 1/2 cosine 4x dx equal 1/8 integral 1 minus cosine 4x dx. And then we can calculate the integral now. Equal 1/8 times integral 1 dx is x, and minus sine 4x. Don't remember divided by 4 plus c equal 1/8 x minus 1 over 32 sine 4x plus c. Next video, we're going to talk about tangent and secant integrals. Hope this video helpful. Thanks for watching.